Good morning, good afternoon, or good evening, class, depending on when you're watching this video. Today we're going to go ahead and look at section 8.2, which is adding and subtracting rational expressions. Remember in the previous section we did multiplying and dividing. Just to remind you, when you multiply and divide, if you're multiplying, you just go ahead and multiply across, so multiply the numerators and multiply the denominators. If you are dividing, remember you multiply by the reciprocal. So today we're going to look at adding and subtracting, so let's look at the example we have provided. In order to produce a picture that is in focus, the distance between the camera lens and the lens Q must be controlled so that it satisfies a particular relationship. If the distance from the subject to the lens is P and the focal length of the lens is F, then the following formula can be used to determine the correct distance between the lens and the film. Okay, so our problem says if 1 over f is equal to 5/6 and 1 over p is equal to 1/4, we need to find 1 over q. So let's go ahead and just start setting that up. Oops. We would go ahead and 1 over f, so we're trying to find 1 over q, so I would just write 1 over q is equal to, now we have 1 over f, so 5/6 minus 1 over p, so 1/4. Now, in order to add or subtract fractions, we need to make sure we have a common denominator. So in this case, my common denominator, well, what can I multiply 6 and 4 both to? What is the least common multiple is what we will call it. Well, I can multiply 6 to 12 and 4 to 12. I would multiply this by 3. And whatever I would do to the denominator, I also do to the numerator. To get 6 to 12, I would multiply by 2. Okay, so 1 over q will equal 2 times 5 is 10, 2 times 6 is 12, minus 1 times 3, which is 3, over 4 times 3, which is 12. Now, when you are adding or subtracting, recall that the numerators, you perform the operation. So 1 over q will equal 10 minus 3 is 7, and your denominator stays exactly the same. Then the last thing I would need to do is check, well, is 7 over 12 reduced all the way? And yes, it is. Okay, so there is 1 over q. So we're going to be doing this today with rational expressions. So least common multiple of polynomials. That was the value that I found, the least common multiple between 6 and 12 for my denominator. So we're going to need to be finding a least common multiple this time of polynomials. So in order to do this, make sure the polynomial is in factored form. That will help out. And it contains each factor of the greatest number of times the factor appears. Okay, so it kind of sounds a little confusing, but I'll make it make sense here in just a second when we look at an example. So just to refresh your memory, the LCM of 6 and 4. Well, we can just see that's 12, but when we start dealing with bigger numbers, we might not. So we have 2 times 3 will give me 6. So if I just factor it down to its primes, so I would have 2 times 2 is 4. So it says the greatest number of times the factor appears. So if I look at my 2, the 6 only factors down into 1 2, and the 4 factors down into 2 2s. So to find my least common multiple, it's going to be the greatest number. So 2 times 2, and then if I look at my 3, how many 3s is there? The biggest number of 3s. Well, there's only 1. So it's going to be 2 times 2 times 3. Maybe. There we go. So 2 times 2 is 4, times 3 will give me 12. And that was the least common multiple that we had before. Now if I'm looking at polynomials, we want to make sure it's in a factored form. So the first one we have is p minus 3. I can't factor that any further. And if I go ahead and factor this next piece, I say, remember what multiplies to negative 27 but adds to 6. Well, 9 times 3 will give me 27, and I want a positive 6, so it's going to be positive 9 minus 3, because when I add those two, I will get 6. Now, in order to figure out, well, what is the least common multiple, it's the greatest number. Well, the first piece has a p minus 3, and the second piece has 1 p minus 3, so the LCM will be p minus 3, and then p plus 9, because there's only 1 p plus 9. So that would be my LCM of those two polynomials. Okay. So steps to finding the least common multiple. You want to factor all polynomials, then multiply each polynomial by the factors it is missing, and we're going to use each factor the greatest number of times it appears as a factor. So that's what I'm talking about. There was only 1 2 from 6, but there was 2 from 4, so we would use the bigger number of 2's. Okay, so let's just go ahead and start looking at some examples of least common multiple. So we want to find the least common multiple between these two numbers. So what I recommend is going ahead and branching off and factoring out each one of these values. Okay, 12, well, we know it's 2 times 6, which 6 is really 2 times 3. So 2 times 2 times 3 will give me 12. 27 we should know is a cubed root. So it's 3 times 3 times 3 will give me 27. And then 18, well, it's 2 times 9. So 2 times 9, and then my 9 can factor down into 3 times 3. So now in order to find my least common multiple, we take the greatest number. Okay, who has the biggest? Well, if I look at 2's, there's 2 2's here. There's no 2's here, and there's only 1 2 here. So it's for sure going to be 2 times 2 times, now I look at 3's. There's only 1 3 here. There's 3 3's here and 2 3's. So it's the biggest number. 3 times 3 times 3. Okay, and there is no other factors. All right, so then I go ahead and look at the variables, and I pick the greatest number. So this is a squared, a to the first, and a to the fifth. So the biggest one is a to the fifth. Then I have b to the fourth, and b to the second, so it's going to be the bigger one, so b to the fourth. And then I would go ahead and I would look at c. There's a c to the third. And obviously I would simplify this. I would say, well, I know 2 times 2 is 4, and 3 times 3 times 3 is 27. And if you type that in on your calculator, if you're not sure, you would get 108. A to the fifth, b to the fourth, c to the third. Okay. This is going to be important that you can do this when we get to adding and subtracting those rational expressions. So we need to do some practice with finding the least common multiple. So example 3. All right, here's example 3. Same idea. I'm going to go ahead and break each one apart. I know that 6 is 2 times 3, and 42, well, it's going to be 2 times 21, and 21 will break down into 3 times 7. And then 36 is, well, we could do 6 times 6, or I could break it down, it's divisible by 3. So I'm going to do 6 times 6. And then each 6 will break down into 2 times 3 times, and then 2 times 3. So same idea as before. I say, well, which piece has the greatest number? There's 1 2 here, 1 2 here, but there's 2 2's in this piece here. So I would have 2 times 2. Then I look at my 3's. There's 1 3, 1 3, 2 3's, so times 3 times 3, and then times 1 7. This is a 2 here. Then I would go ahead and look at my letters. I would have, or my variables, I have m to the third, m to the third. So my highest value of m is m to the third. N to the fifth, n to the first, n to the fourth. So n to the fifth it is, because it is the highest exponent. Now I'm going to move on to p squared and p, so it's going to be p squared. And is there any other variables? No, there is not. So now my hardest part is to say, well, what's 2 times 2 times 3 times 3 times 7? Well, that will give us 252, m to the third, n to the fifth, p to the second. And there is my least common multiple for those. Example 4. Now we have polynomials, okay? So we're going to go ahead, before we had monomials, now we have polynomials. So let's go ahead and factor these first. If I look at this first piece, I notice I can factor out a p. So I would have p squared plus 5p plus 6. If I go any further, I would have to say, well, what multiplies to 6 but adds to 5? Well, 2 times 3 is 6, but when I add them, I get 5. Now I will go ahead and look at the other piece. I don't have a GCF here, so I can just go ahead right away. What multiplies to 9 but adds to 6? Well, plus 3 plus 3. So in this case, I have to pick the greatest. Okay. Well, this one has 2 p plus 3's, so I would write for my least common multiple, it's going to be p plus 3 times p plus 3. And then I would have 1p, I'm going to write that in the front, and I would have a p plus 2. Okay, which will simplify. We would write it as p, I'm going to write p plus 2, and then it would be p plus 3 since they are squared because there's 2 of them. There's my least common multiple for example 4. Example 5, let's go ahead and look at that one. Okay, example 5, I'm going to factor. So I would once again say, well, what multiplies to 4 but adds to negative 4? Well, p minus 2 and p minus 2. And my other piece, I would factor out I was using p's. They should be q's. Okay, they should be q's. So q minus 2 and q minus 2. From the second part, I'm going to factor out a q. So I will have q squared minus 3q plus 2. From this, I would say, well, what multiplies to 2? Well, that's easy. Only 2 and 1. So I would have 2 and 1. And then what adds to negative 3? So that means they're both going to be negative. Then to find my least common multiple. Remember, you take the greatest of each factor. So over here I have 2 q's. Q minus 2, so I would have q minus 2 squared. Okay, I would also have q minus 1, because there's one of those, and then also q. So that would be my LCM for example 5. Example 6, let's go ahead and look at that one. Example 6, we have x cubed and minus x squared minus 2x. So I'm going to factor out an x for this first one. And then I would say, well, what multiplies to negative 2? But adds to negative 1, well, once again, there's only one option that multiplies to 2 times 1. And to get negative 1, I would have negative 2, positive 1. Then I will go ahead and look at the second piece and factor this one. I can just say, well, what multiplies to 4 but adds to negative 4? And we did that one above. Actually, we're going to have negative 2 and negative 2. And then least common multiple will be the greatest of the factors. So I have 2x minus 2 squareds, and then we have 1x plus 1 and 1x. So it'd be x plus 1, and since there's 2, it's x minus 2 squared. And our last example for finding the least common multiple on the front side. Is example 7, and I would recommend that you go ahead and try that one on your own. So if you want, you could pause the video and go ahead and try that one, and then I will come back and do that one. Sorry, I'm just trying to put it onto another screen so it's easier to see. All right, sorry about that. Here's example 7. So in this case, I would factor out a k from the first polynomial. So I would have k squared minus 5k minus 12. Oh, this should be 2k squared, my bad. Now I would have to go ahead and I can either use factoring by grouping or I can do guess and check. So I'm going to start with guess and check. I know that I have to get to 2k squared. So 2 is nice because it's a prime. And then I would go ahead and think about what's going to multiply to 12. Well, let's just try 3 and 4. Okay. And then remember, it's your two inners, which will give you 3k, and your two outers that have to get to negative 5k. So this would give me 8k. Well, could I get there? Yeah, this would have to be negative. So that means when I multiply 2k times 4k, that would have to be negative, and this would be positive. So there it is, factored by guess and check. Remember, if you didn't get it, you could try other factors of 12 or switch 4 and the 3 around. But that's how you would do that piece. If you wanted to do by grouping, what you would need to do is you would take 2 times negative 12, which gives you negative 24. And I would think of my factors from negative 24 that multiply to negative 24 but add to negative 5. Well, negative 8 and 3. And then I would rewrite it as 2k squared minus 8k plus 3k minus 12, just to refresh on grouping. Then I would break it apart, and I can factor out a 2k from this, so I would have k minus 4. And out of here, I can factor out a 3, so plus 3k minus 4. Notice how there is 2k minus 4s, so I'd factor 2k minus 4, and then whatever is left. So 2k plus 3. And look, that's what I got from above. And I would still make sure to include the k that I factored out from earlier. Okay, so my factored form for my first piece, I'm just going to rewrite it so it looks clear, would be k, 2k plus 3, and k minus 4. Now let's go ahead and factor the second piece. Once again, I need to factor out a k from this piece. So I would have k squared minus 8k plus 16. And now I would say what multiplies to 16 but adds to negative 8? Well, negative 4 times negative 4 is positive 16, but it adds to negative 8. Now I would go ahead and find my least common multiple. Okay, so for sure I have k minus 4 squared. I'm going to have a k and then a 2k plus 3. So k, 2k plus 3, and k minus 4 squared. All right, we're going to go ahead and stop the video there for today. I'm going to pick up part 2, so I would recommend maybe taking a little bit of a break, going and doing something else, and then coming back and watching part 2 of the video. We're going to actually start adding and subtracting rational expressions on the next video, and that's when you're going to need to use your LCM. So take a break, come back, and watch part 2. Otherwise, have a great day, and I'll see you later.